Welcome back to Maths with Armien. In this video on Circle Analytical Geometry, which is part one of two parts, we're going to look at the introduction of some circle concepts. Let's see what we're going to do in this lesson here. We're going to start off with equations of circles with center AB, and then we're going to look at equations of tangents to circles, and then applications of these circle concepts, and then as usual with all my videos there'll be an exercise worksheet. Let's start with equations of circles with center AB. Let's start off with deriving a formula for the equation of a circle with center at the origin. So there we have a circle. If you look there, the center is at the origin. There's a point on the circle. Let's say it's point A, which is xy, and OA is the radius, and let's denote the radius by a r. Okay. Now, if you look at that, if you draw a perpendicular line to point B, what do we get? We get the y value of AB would be y, and OB would be x. Now, because AB is perpendicular, it means I have a right angle triangle. And with a right angle triangle, I associate the theorem of Pythagoras. So let's apply the theorem of Pythagoras there. We see OB squared plus AB squared is equal to OA squared. But OB is x, AB is y, and OE is the radius. So there we have a formula for the equation of a circle with the center at the origin. So if the center is at the origin, this is the equation of a circle that we will use. Now let's just derive a formula for the equation of a circle where the center is not at the origin but at point AB. Let's look at this graphically. So there we have a circle. The center is at M, it's not at the origin. There's the radius of the circle, and there's a point on the circle there. Now we can find the radius length, in other words AM's length, by using the distance formula. And if I apply the distance formula, AM squared will be the XA minus the XM all squared plus the YA minus YM all squared. We substitute there, XA is X, XM is A, that is Y minus B, and there's the equation of the circle. If the center passes through, the center is at A, B. Let's start off with equations of circles with the origin 0, 0, the origin of the Cartesian plane, as center of the circle. Here we have a formula that is provided to you, x squared plus y squared equal to r squared. And this is the formula that we're going to use here. So we want to find the equation of some circles. Let's start off with the first one. Here we have a circle, so let's look at what we are given here. We have a circle, you see the center is at the origin, and we're giving you OA. And what is OA? OA is the radius of the circle. So we can directly apply this formula here. We know that, so that will be x squared, right? So we just have to substitute r equal to 4 into this formula, and that gives me the formula x squared plus y squared equal to 4 squared, and 4 squared, you know, is equal to 16. So if we have the radius and the center is at the origin, you just have to substitute the radius value there. So if this is going to be 5, that's going to be 5 squared. If this is going to be root 3, that's going to be root 3 squared. Let's look at another example. Here we again have a circle, and the center is at the origin, but we are not given the radius, the length of the radius. We're giving a point on the circle. So let's see what we have here. So we can still use this formula, because this formula is the formula for having the a circle with the center at the origin. So we have the x and the y value. So we can just substitute the 2 and the 3. 2 into the x, 3 into the y, and that will give us the value for r squared. And r squared, we notice, is 13. Now we can replace the r squared. So x squared plus y squared will be equal to 13, and there's the equation of the circle. Now let's look at some examples of circles where the center is not the origin. You see the center, A is not a 0, B is not a 0, right? And the equation that we'll use for circles where the center is not the origin, there we have the formula x minus a all squared plus y minus b all squared equal to the radius squared, where a, b, those are the coordinates of the center. Let's look at our first example. Here we have a circle. As you can see here, there's the origin. The center is not the origin. So if the center is not the origin, we have a coordinate for the center, and there we have, so we have the radius measurement. In other words, we can replace the r, and we just have to put the coordinates of the center into our formula. So this is quite straightforward. So it's, you see there's a plus 1, so this becomes x minus 1. There's a plus 2, so that becomes x minus 2 squared. And then we put in 5, and 5 squared, we don't leave it as 5 squared, we write it as 25. So it's very straightforward. Just put the center's coordinates in there and the radius measurement. Let's take another example. Again, here we have a center at -3 and -1. So that -3 is going to become, that's correct, a +3. And that -1 is going to become a +1. And then we just have to substitute the r equal to square root of 5 in the formula. So let's do that. So that's x plus 3 all squared plus y plus 1 all squared. And that root of 5 squared becomes, that's correct, 5. You can leave your equation in this form unless they require it in another form. Give it in this form here. X minus a all squared plus y minus b all squared equal to 25. Let's look at a few other examples where we're going to use this formula here. X minus a all squared plus y minus b all squared equal to r squared. This is the equation of a circle where the center is not the origin. Let's look at this example. So we have a center, in other words, we know the a and the b value, but what don't we know? We don't have the radius length, so we have to work out the radius length first, right? So how do we find the length? The length there, we can just use the distance formula. If I apply the distance formula, which should be very basic, -1 subtract -3, -4 subtract -1, you square them. So instead of r, we can just work out r squared, because the formula would like r squared. And that's 13, so the radius is actually, although r squared is 13, the radius is actually square root of 13, right? Now we can substitute into the formula. We know the a value is -3, so that becomes +3. The b is -1, so that becomes +1. Watch out here. -3 becomes +3, -1 becomes +1. And there we already worked out r squared is 13, so there's the equation of that circle. Let's look at another one. Let's see what we have here. This formula requires a center and a radius length. You can see there's no radius length, so we'll have to find the radius. We also don't have the center. Now center also means the, what do you call the center there? The center is actually the midpoint of the diameter as well. So we find the, so first of all we have to find the midpoint, because we need to find the center. So if we find the midpoint of from -1 from a to b, there's an, so the center we can calculate -1 plus 5 over 2 and 1 plus -3 over 2, that gives me 2 and -1, and it's advisable when you calculate that, just insert it in your diagram there. So now we've got the center. So a is 2 and b is -1. But what do we also need? We also need the radius there. And to find that radius, we use the, that's correct, we can use the distance formula. So I can either work the distance from a to the center or from the center to b. Let's try, here we have from a to the center. And if I apply my distance formula, which should be very easy for you here at grade 12, be careful that you don't make any mistakes. You can just input that directly in your calculator. Even numbers are small, you could even do it mentally. That is 13, but don't be careless with that. So r squared is 13, which means the radius again is square root of 13. So I can then substitute, so that 2, that becomes negative 2, negative 1 becomes positive 1, and r squared is 13. So there we've got the equation. Now just look at these two examples again. Here we had to work out the radius, because you cannot find the equation without knowing the length of the radius. Here we also don't have the radius, but we also don't have the center. So I need to work out the center by using the midpoint formula there. And once I have the center, I can work out the length of the radius. I could also have worked out the length of the radius right from the beginning. How could we have done that? That's correct. We could have worked out the length of the diameter and divided by 2. But in any way, we still had to find the coordinates of the center of that circle. Now let's look at some examples where the equations are given, not the diagram. So we want to find the coordinates of the center and the length of the radius of the following circles. We'll always need this formula here, right? That formula is available. So let's look at this one. Let's compare this to this formula. We can see there's a negative and a negative. So what will A be? A will be 2. There's a negative B and there's a negative 3. So B, that's direct reading off there. So that will be 2 and 3. And the radius, there's r squared, there's 5 squared, so the radius is there. So this here we can actually just read it off. That's why it's normally said there, write down. No calculations, you can just look at the equation and compare it, and then you can write down the coordinates of the center and the radius. Let's look at the other one. Yeah, let's compare that. So there's negative A and there's positive 4. So what should A be? That's correct. A should be negative 4. There's negative B and there's negative 1. So B is just 1. And the radius, there it says r squared. So r squared is 16. So r will be, that's correct, the square root of 16, which is equal to 4. Let's look at this one. There we have x minus a squared. There we only have x. So what's the x coordinate here? That's correct. It's 0. There's y minus b. There's y plus 6. So that will be negative 6. So 0 and negative 6. And then the radius, right, r squared is 10. So r will be square root of 10, and leave it here in the cert form. So you just have to compare the given equation with that. So you can actually, that's why it says write down. No calculations. You should be able to write down the coordinates and the length of the radius. Let's look at some further examples here. There we have the equation of the circle. So we again want to find the coordinates of the center and the radius. But here, the equation is not given in this form here, the standard form. It's given in this form. So we have to find the center and the radius. In other words, we have to write this into that form first, then we can do that. The same with this example. We'll have to write this into that form and this into that form. So let's look at the solution on the next. So there we have our formula, which is given to us. So let's take the first one. So what I need to do is I need to write this equation in that form. So let's start off with the form first, right? And the method that we're going to use here is the method that we did in grade 11 on completing a square. But we'll just show you the very simple way of doing that. So this is the format that I want. That plus sign will remain a plus sign. Here, when we completed the square, we needed to take half of that. And what is half of 4? 4 over 2, which is actually 2. So that, right? So that plus sign will, that positive will remain a positive, and that negative there will remain a negative. Let's sort out the signs first. Half of 4 will be 4 over 2, right? And which is 2. And 6, half of 6 would be 6 over 2, which is 3. And then now we need to balance the equation. Whatever we did on this side there, I've got a 2 squared, so I must add a 2 squared on that side. There I've got negative 3 squared, and when it doesn't matter whether it's negative, the square is going to make it positive. So I'm taking a 3, so I add a 3 squared. Never use a negative sign there, right? So that's what I have there. Now I can just simplify this part here. 4 over 2 is a 2. You don't use a calculator for that. 6 over 2, 3. That would be very embarrassing if you do that on the calculator. This maybe you can do on the calculator and you get a total of 23. Now we can read off the center. If that's a positive 2, the center will be negative 2. That's a negative 3, that will be positive 3. And the length of the radius is square root of 23. Let's just briefly go over that. You can write from this directly into this form. That positive will remain a positive there. That's just half of 4. You can just do it. You can actually skip this part here. 4 over 2 is 2. 6 over 2 is 3. And then whatever you add on this side, you add on the other side. It must be balanced there. And never use a negative, because when you square a negative, it becomes a positive. Now let's look at our second example. We're going to need that formula. We want to find the coordinates of the center and the radius of the following circles. Let's look at the second example. Now, it's important here that you have to have this equation written in the correct order. So we must rearrange the term. First the x terms, then the y terms in y, then the constant on the other side. So, and I've also color coded the numbers here, so it's easy for you to see what happens to that 8, what happens to that 3. Again here, we're going to use the method of completing a square. So there's the equation again. So this is what we want to attain. We want to have x minus the 1 value, and if that negative will remain a negative, that positive will remain a positive there. Now, let's look at 8. Half of 8 is 8 over 2, which is 4. Half of 3 is 3 over 2, which is 1,5. We want to complete, so we have to add on both sides. I have to add 4 squared. I have to add 3 over 2 squared, or 1,5. 8 over 2 is a 4. 3 over 2, maybe it's easier to write it in decimal form, 1,5. This you can calculate, and we end up with 26,25. Now we can read off the center. So that's a negative 4, it becomes a 4. That's a positive 1,5, it's negative 1,5. And the radius there is square root of 26,25. And they want it rounded off, it's approximately 5,12. Okay, so just make sure that the terms are arranged, first the x terms and the y terms. So they can also give it to you like that. So just be a little bit more careful there. Now let's look at one more example. So again that's the formula. We want the coordinates of the center and the radius. Now as you can see, the difference here is that this equation here starts with a 2. We've got 2x squared and 2y squared. So we don't want that. So we have to divide right through by 2. Divide everything by 2. I am ready to have that. It's already in the correct order. I first have my x's, then my y's, then my equal and my constant there. So let's get the template again. Again, color coded, so we can see what happens to that 10. That positive will remain a positive. That, and there again it's just y, so I don't have to do anything there. Half of 10 is 10 over 2, which is 5. And there's nothing there, so it just remains a 0. So half of 10 is y. Add the 5 squared, and that there I don't have to add anything there. I don't do anything with the y squared. Simplifying it, 10 over 2 is 5. That's y squared. Now I'm ready to get the coordinates of the center. Positive 5 is a negative 5, and that is the coordinate there is 0. And then the radius there is square root of 33. Let's look at another concept here. We would like to determine whether a given point lies inside or outside a circle. Okay. So let's look at an example here. Determine whether the following points, so there are 3 points down here, whether these points lie inside, outside, or on this circle. So let's take the first one, 4 and 6. How do we do that? 4, 6, that's the x value and that's the y value. So first of all, let's substitute that into the left-hand side. So we're only substituting the left-hand side of the circle's equation. And if we substitute that substitution, you can actually do this without a calculator, but to be safe, 9 plus 16, and that gives me 25. So that 25, we now notice, is equal to that right-hand side there. Now, if this substitution on the left is equal to that 25, then we'll say that the point lies on the circle, because that satisfies the equation. So the left is equal to the right, so it's a point on the circle. Let's take the other point 2 and 3. Let's substitute that. And if we substitute that into the left-hand side, we end up with a 2. Now, if I look at 2, 2 is not equal to the right-hand side. 2 is, in fact, that side 2 is less than the 25. And because it's less than the 25, we will say it lies inside the circle. So if it's equal, it's on. If it's less, then it is inside. Let's take the third example. Let's substitute that point, substituting that, and we end up with a 34. Now compare this 34 on the left with a 24 on the right. 34 is greater than 25. And when it's greater, the point lies outside the circle. Let's just go over that. When the left-hand side is equal to the right-hand side, the point lies on. When the left-hand side after substituting is less than the right-hand side value there, then that's going to be inside. And here, if I have the left-hand side greater than that, remember this is the radius, right? So the radius, if I do this, I end up with a 25, so it's exactly the same radius, so it's on there. Here you see it's shorter, right? This r squared is going to be 2, not 25, so it's going to be inside. Here the r squared is 34, which is more than the 25, so it lies outside the circle. Now let's look at some other examples. Next, we would like to determine, whether two given circles, whether they touch each other or they intersect each other, right? Or they don't touch or intersect, right? So let's see, determine whether the pairs of circles, so there we've got 3 examples. We're going to look at this pair and see whether the two circles either touch, intersect, or they don't. And this one here, again, there's another example there. So there are 3 examples we're going to look at, and that we'll do in the next slide. Let's look at our first pair of circles. First of all, what we have there, we need to understand there we can get the center and the radius. We can get the center and the radius. You know what the center would be? 1 and 1, radius 5. 10 and 13, radius 10. Right? So that's just from the equations, you should be able to do that. So first of all, we're going to determine the distance between the two centers. Right? So we need to identify the centers. As we said earlier, it's 1 and 1. Let's call that center M. That one is going to be 10 and 13. How do we find distance? That's correct. We use the distance formula. And calculating that distance, I see the distance between the two centers is M. Now we want to find the sum of the two lengths of the radii. What were the two radii? That's correct, 5 and 10. So we add them. And now we see that this sum here, which is 15, is exactly the same as the distance between the two centers. Right? Therefore, if we compare the sum and the distance, we see they are equal. And when they are equal, it means the two circles touch each other. Okay, so there you can see that was 5 and 10 in the distance, so the two circles will touch each other there. Now let's look at our second pair of circles. There we have 2 circles. First of all, let's see what we have here. The center, what are the centers? 1 and 1, and the center is 10 and 13. This one's radius is 5, and that one's radius is 8. So from the equations, we can get the center and the radius. Now let's find the distance between the two centers. So let's get the two centers. They are the two centers, 1 and 1, 10 and 13. Let's call them M and N. Distance, we use the distance formula. So the distance there is, in this case, it ends up as 15. Let's add the two radii together. So there's the two radii. The one is 5 and the other one is 8. 5 and 8 is 13. Now let's make a comparison between the 13 and the 5. Right? Let's compare them. We notice that the distance between the two centers is more than the two radii. Okay? And that implies there that they do not intersect or touch. Let's look at it diagrammatically. Can you see that is 5 and that is 8, but the distance there was 15. So that 15 is more than, you see there's an extra 2, a gap between them. Therefore the two circles do not touch each other. So if the distance is greater than the sum of the radii, then the circles don't touch each other. Let's look at the third pair of circles. Again there the center again is 1 and 1, and there we have a center 10 and 13. This radius is 6 and that radius is 10. So we have the two centers, coordinates of the two centers, M and N. Let's find the distance. We find the distance is 15. Now let's add the two radii lengths together, right? So if I add the two, the one is 6 plus 10, that is 16. Now let's compare. That 16 we can see is more than, okay? And if it's more than, then they intersect each other. Let's just look at it graphically. You can see here that I have, there is M and N, that distance is 15, but the two together is 16. So they definitely, that distance is shorter than the sum. Therefore the two circles will. Next we're going to look at how we can find equations of tangents to circles. Let's look at our first example. In this example we're going to take a circle where the center is the origin, just to get the concept there, right? So let's see how we can go about that. If I want the equation of a tangent, I'll first of all, because I have the center and I have that given point, I'll have to find I definitely need the gradient, but I need the gradient of the radius. So the first thing is to find the gradient of the radius. In this case it's OA, the gradient of OA. Next, and I can use that formula to find the gradient. So once you calculate the gradient, I now need to find the gradient of the tangent. But I need to know a property about a radius and a tangent there. That's correct, they are perpendicular. So I'm going to use that concept that the radius, so I can use that gradient to find the gradient of the tangent. For example, if this one is 4, the tangent will be negative 1 over 4. If this one is 2/3, that one will be negative 3 over 2. Then we have to find the equation of the tangent. And the equation of a tangent is a straight line. So I just use my straight line formula. I can take the tangent's gradient, which I will have as my m value, and they give me the coordinates m and n. So I'll just have to substitute in there. Okay. Now let's look at an example. There I have a circle, and you see it as a center at the origin, and it's a tangent at the point 3, 4. And the tangent is referred to as AB. It's this purple line here. So I want to find the equation. So the first thing I do, find the gradient of the radius. And there's the gradient, OA. So I find the gradient of OA, and that is going to be 4 over 3. Now I need to find the gradient of the tangent. But because it's perpendicular, if this is the radius has a positive gradient, the tangent there would be, see the gradient is positive, the tangent will be negative. So that will just be negative 3 over 4. Right? Just straight from there, positive, that's negative. 4 over 3, you just find the reciprocal, 3 over 4. They're not identical. Next, I have to use my equation, and that's the equation. Now I just have to substitute the negative 3/4 in there. And the point, which point? Not the 0 and 0. The tangent doesn't go through the origin. Tangent goes through A. So I substitute that. Substituting that, removing the brackets, transposing the 4, and there I have the equation there. And you can see this is a negative line, and it has a positive y-intercept. And you see there's the positive y-intercept there. So you find the gradient of the radius, you use that to find the gradient of the tangent, and then it's just substitution. That's a very basic procedure there. Now let's take an example of a circle where the origin is not the center. As you can see there, we have a circle with center at M, which is 2 and negative 1. There's the center M, and there we was a tangent. But we'll follow exactly the same procedure. The gradient of the radius, and that gradient is MB. So I can calculate that gradient. And the gradient there, we can see it's a negative. So it's negative 2 over 3. Now we need to find the gradient of the tangent. And you know this one, they are perpendicular. So if this gradient of the radius is negative, the tangent one there will be positive. If that is 2/3, the other one will be the reciprocal, which is 3/2. Right, you can do that straight. This is actually concepts that were taught in grade 10 already. You don't have to do long calculations. Negative, that becomes positive. 2/3, that becomes 3/2. Then we can use the equation formula. It's advisable to use this one, the gradient point version of the formula, substituting the m and the point. And the point we're substituting is B, not the center. Be careful, don't substitute the incorrect point of contact. And we remove the brackets there, and we end up with that. We can see it is a positive gradient, and you can see the y-intercept is going to cut somewhere on the negative side, and we do have a negative value there. Let's look at another example. It will be slightly different. There's no diagram provided here. So we want to find the equation of a tangent at point P to the circle, right? So if that is a circle, we need to know something about the circle. Because if I want the tangent, remember what we need? The gradient of the radius, and there I need the center. So we'll first have to find the center of that circle. And we did this before. That's a negative, that becomes negative. That half of 2 is a 1. That's a 6, so that's positive. The half of 6 is 3. We add a 1 squared, and there we are. We're not interested really in the radius length. We only want to find the center of the circle. And the center, therefore, is 1. And now we're ready to find the equation of a tangent, irrespective of whether we know what the sketch looks like. So the gradient of the radius, so it's from the center. So I've used the center point and to the point 24. And, right? Then we'll have to find the gradient of the tangent at P. And we can use, so first of all, the gradient of the radius. There it is. I use 4 subtract negative 3, and then 2 subtract 1. And that gives me a 7. So the gradient of the tangent now, if this is 7, the other one will be, that's correct, it will be negative. And the reciprocal of 7 is 1/7. Remember, they're totally different. That's positive, that's negative, that's 7, and that's the reciprocal. Now we're ready for the equation. So it's just a matter of substituting. We substitute in the negative 1/7, and it must go through 2 and 4, not through the center. Be careful, don't substitute the wrong values. 2 and 4. And if we remove that bracket, there is the equation there. Okay, so in this case here we needed the center. This one is just a higher, just slightly a little bit, one additional, because we needed the center there. You don't really need to have the sketch for that. Now we introduce some problems and just apply these concepts of circles that we just illustrated to you in the previous slides. Let's consider the following example. We have a circle with a given equation, and we want to calculate the length of the tangent. And this tangent is drawn from point A with B. Let's look at the diagram. So there's the circle, and I want the length of AB. A is given, so let's say that if it's not in your sketch, make sure you've inserted it in the sketch. Now what do we know from that? That's right, you can get the center and the radius. So they give it to you in that form. They're actually giving you two things. They're telling you what the center is and what the radius is there. So find the center, it's just writing down the center. And when you have that, it's advisable just to insert it in your sketch. So there we're putting it in the sketch there. Now we want to do this. If I want AB, I need to find the length of the radius. What is the radius? MB, but we don't have B. How can we find? Remember, we said we do have the length of the radius from the equation. We don't have to calculate that. So the length of the radius can just be written down, which is 5. Let's insert that in the sketch so we know that's a 5. Now we want the length of AM. And if I find AM's, I have A and M's coordinates, so that I can just use my distance formula. Applying the distance formula correctly, I end up with 25/3. Let's insert that 25/3. Now we're coming to the actual objective. Find the length of AB. Let's see, there's AB. What is this? A radius. And what is this purple? Magenta. It is a colored line. It's a tangent. What do we know about that? That's right, they're perpendicular. So what type of triangle is MBA? A right angle triangle, which we associate with the theorem of Pythagoras. So we can work out AB just using the theorem of Pythagoras. There we apply the theorem of Pythagoras, substitute, and if we calculate, The length of AB is 20/3. Let's look at one more problem here. We have a given circle, ABDC. We look at the diagram. You can see there, ABDC, right? And we have a center which is given in there, -3 and 3. And we have point A, there's point A on the circle. And you want a tangent at point D. So we've got a tangent here at point D. And C and D are x-intercepts and B is a y-intercept. Now these are the questions. Find the equation of the circle. And we have to find the coordinates of point B. And then we want the coordinates of point C. And then we want to find the coordinates of D. So always make sure that the given information you understand. There's that. I know AM is a radius and MD is a radius. I also know a radius and a tangent is. That's right. It's perpendicular. Right? B is a y-intercept. I should know something about y-intercepts. C and D are x-intercepts. I also need to know something about the coordinates of x-intercepts. Now in the next slide we're going to look at our first question. There's our diagram. We want to find the equation of a circle. Now what do we need for the equation of a circle? We need the center. Do I have the center? Yes. Do I have the radius? No. So I'll have to calculate the length of the radius. So first of all, I need to work out the length of the radius. In this case, it's AM. And if we calculate the length there, it ends up as a 5, substituting the A and the M's coordinates. Right, that's grade 10 level question there. Now to find, so there I've got the radius. The radius is 5, right? So my equation then will be -3, that becomes +3. That's 3, that becomes, and 5 becomes, and there's the equation of the circle. Let's look at the next question. The coordinates of B. Now, whenever you have to find the coordinates of a point, you normally ask yourself two questions. Where is the point and where else is the point? If you see that, where is B? That's right, B is on the y-intercept. And what do I know there? X is 0. Where else is B? B is on the circle. So I have to use the circle's equation to find B. Okay, so I just have to substitute 0 in there. Why the 0? Because the x-intercept is, the y-intercept, the x value is 0. So I substitute 0 into that equation. And now I can simplify. 3 squared is 9. Subtract 9 from 25, which gives me 16. And then to solve that, I can just find the square root. That's right. So it's plus or minus the square root of 16, which is plus or minus 4. Now there are two options there. I can have 4 plus the 3, or I can have -4 plus 3. So I get a 7 and a -1. But you can see the B value there is a positive value. So that B coordinate has to go with the 7. So B's coordinate is 0 and 7, not 0 and -1. That 0 and -1 is the other y-intercept there. Okay? So always when you want to find coordinates, ask yourself two questions. Where is the point? And then the next question, where else is the point? So you'll have to use two things to find that. Because a coordinate needs two parts. It needs an x-coordinate and a y-coordinate. A point has two coordinates. It needs an x-coordinate and a y-coordinate. Now let's look at our third question. There's our diagram again. And let's insert the 0 and the 7 from the previous question in case we need it. Find coordinates of C. What do we say? Where is C? That's right. C is on the x-axis, and if it's on the x-axis, the y-coordinate is 0. Where else is C? C is on the circle, so I will have to substitute that 0 in the circle's equation, right? Substituting the 0, that's y equal to 0, and 3 squared is 9. 25 subtract 9 is 16. Again, I can find the square root of 16, and again, remember it's plus or minus. So there are two values for x. Either a -7 or a 1. 4 subtract 3 gives me 1. -4 subtract 3 gives me -7. Now which one is the C? Now look at the diagram. C is the -1. So C's coordinate is -7 and 0. Right, let's insert it in case we need it. Find the equation of the tangent. How do we go about finding equation of a tangent? That's correct. We need to find the gradient of the radius. And what's the radius there? and I've got d in 1 and 0 from a, okay, so the gradient of the radius is, that's md is the radius, and the gradient of md, if we calculate it using the m and the d, gives me -3/4. Gradient of the tangent, if this is negative, the other one is positive, and the reciprocal of 3/4 is 4/3. Then use the equation, so it's just a matter of substituting 4/3, but now which point? It's the tangent at D, so I must substitute D's coordinate, no other point but D. And if I substitute that, I get the equation there, 4/3x plus 4/3. Let us consider another example. There we have our given information, and there's our diagram. Let's just try to relate the two. You've got the diagram. P is a point, so there's point B. ABC is the circle, so ABC, there's the circle. AB is the diameter, so obviously it goes through the origin in this case. And then ACD is a straight line, there's ACD a straight line, and BD is a tangent. So try to make sure you understand everything that's given. This is a circle with the origin as center. Now there are 4 questions we're going to look at, and that we'll do in the next slide. Let's look at our first question. There's our diagram. Let's make sure we've got everything there. Determine the coordinates of A. What did we say? We asked ourselves, where is A? Right? So if I look at A there is on 2 things. It's on the diameter and it's on the circle. What do I know about the diameter? OB is equal to the distance from OB and to OA. It's exactly the same. So let's see there. So I can actually do this by inspection. From 3 I go to 0. So from 3 to that x coordinate of 0 means I subtracted 3. So I subtract 3 from 0 again. So I end up with -3. There from -4 I go to 0. So I've added the 4. So I add 4 to the 0 there. Gives me, so the coordinates of A are -3 and 4. Actually this is a reflection there, right? So that gives me -3 and 4. So A's coordinate is -3 and 4. Determine the equation of the circle. So equation of a circle, we need the radius. So the radius length, I can either work out OA's length or OB's length. Doesn't matter. If I work out any of the 2 lengths, I end up with r squared is 25. So my equation, because it goes through the origin, it's this formula, x squared plus y squared is equal to 25. Now, determine the equation of the tangent. So what do we need? We need a radius, and we have a radius OB. I can find that gradient. And I can use that to find the gradient of the tangent, and then I'll just have to substitute. So let's do that. Gradient of OB is -4/3. Gradient of BD, it's perpendicular, so it's going to be +3/4. I use that equation, and I end up with 3/4 as my gradient, and my point I'm substituting is 3 and -4. So that's -3, and that -4 becomes a +4. Transposing and simplifying, there's the equation of the tangent. Now let's look at the last question here. Sub-question. There's our diagram. We've got point A was calculated. We worked out point C, and we want to determine the coordinates of D. Remember what I suggest we always do? Where is D? D is on the tangent. Where else is D? D is on the straight line ACD. The tangent, I have the equation of the tangent. So D is the point of intersection of those 2 lines. The equation of BD we just worked out in the previous sub-question. So I must find the equation of AD. What do we need for an equation? We need a gradient. So I can find the gradient of AD, which is the same as the gradient of AC. So let's find the gradient of AC. And if we calculate using point A and point C, I end up with -1/2. Now I want the equation. So there's the equation. I can substitute my gradient in, which is -1/2. And I can use either point A or point C. But which one is the easier one to use? That's right, C is much easier. So rather you substitute point C. It wouldn't have mattered, we'd obtained exactly the same answer. and there I now have the equation of AD. And once I have AD and BD, I can, because they equal, they intersect, so I put the one equation to the other, solve them simultaneously, and then I can get the value of x. But just a tip here, if you have fractions in the equation, you can always simplify that. It's much easier by first of all multiplying by a lowest common denominator. What is the lowest common denominator here? 4. So if I substitute 3/4 times 4, I get a 3. Negative 25 over 4 times 4 gives me a negative 25. Times this with 4, I get a negative 2. Times this, and then it's much easier. And now we can solve for x, and x is equal to 7. This is actually grade 8 level equation there. But they want the coordinates. That's only one of the coordinates there. To work out the y, now I can substitute the 7 either into this equation or that. It doesn't matter which one. And there we have the coordinates of D. Right? So just a reminder again, if you want coordinates of a point, always ask yourself those two questions. Where is the point? And then where else is the point? And then you use those two to find the coordinates of D. Now we come to the most important part, and this is where you have to practice these concepts. But before you actually start with this worksheet, I really suggest you go through some of these worked out problems again, but don't just listen and watch them. Try to do them on your own, and then you compare your answer with the provided answer there, right? Don't just watch. You don't learn from watching. You actually learn from doing. Let's just go through these questions. We're not going to solve them. See there, they want you to work out lengths, you want equations of circles, you want coordinates, and you want show whether something is a tangent, and then you want the equation of a tangent. Very straightforward questions there. The same here, find the center. So there you have that. You must now remember, use completing of the square to do that. Now you must give us maybe some reason why they are perpendicular. Then we want the equation of a tangent. Forward questions. Same with number 3, give a reason why it's 90. Find the length of a radius there, right? Determine the equation. Just think there's a spelling mistake there. Determine the equation of the circle. And then the last question there. Here we have a equation given. Find the center and the radius. We did something similar. Determine whether a point lies inside or outside the circle. And then we want the equation of a circle there. Another question. Here we want coordinates of point E. So remember the idea here. Ask yourself, where is E? It's on the tangent. Where else is E? Now here, E is on the circle, but where else is E as well? That's right, E is on the diameter. So maybe it would be better for us to use the diameter's equation and the tangent's equation instead of the tangent's equation and the circle, because it will be much easier solving two linear equations simultaneously instead of a linear with a quadratic. Now, thank you very much for viewing my video. I would also refer you to there's a part 2 of Circle Analytic Geometry where we do a lot more advanced type of applications of circle concepts, and then there are also other videos that I prepared on calculus and on inverses and on finance, and there'll be others coming. I would appreciate if you subscribe to my channel, then you can get these videos. Whenever I post new ones, you'll be able to see what are the new ones there. And my channel, Maths with Armien. Thank you very much.